did want to go ahead and make a video for this page so that we can do it in SSTS, and also if students have troubles at home, because I know that a lot of you are struggling, and it is the very basics of how we start algebra. And I would really recommend if parents at home are doing this with their students, it will really help parents understanding how we're teaching this. So the problem number 10, the table shows ticket prices at the movie 16 theater. Let A represent the number of adult tickets, C, the number of children tickets, and S, the number of senior tickets. So I'm going to do some explaining here because I find that students are really very confused. So I'm going to go to up to the counter. And let's say I only want 4 adult tickets. Well, then I'm going to do 8.75 times 4, right? But what if I say, oh no, somebody isn't coming. I only am going to get 3 tickets. Now I'm going to do 875 times 3. Let's say I'm doing 875 times 3 and grandma decides to come and she's a senior. Okay? So the prices don't change, but the number of people getting those tickets does. And because the number of people getting tickets changes, that's our variable. And we could have adults, we could have children, or we could have seniors. So with all this background information, an adult ticket is $8.75. If I have 1 adult, it's going to be $8.75 times 1. If I have 2 adults, $8.75 times 2. If I have 4 adults, it's $8.75 times 4. However many adults I have, I'm going to call that A. I'm going to multiply by the total number of adult tickets. I'm going to do the same thing for children. Every child ticket I need is $6.50. If I need 4 tickets for children, it's going to be $6.50 times 4. If I need 8 children's tickets, it's going to be $6.50 times 8. And then I could wrap that. It's going to be the same thing for seniors. So again, I'm going to take the number of adults that I have, multiply it by 875. I'm going to take the number of children I have, multiply it by 650. I'm going to also take the number of seniors I have, multiply that by 650, and add them all together. So here's an example of how this would actually work. Okay? So we're going to do what's called substitution, which means we are going to substitute in numbers or values for A, C, and H, depending upon the problem. So the Andrews family bought 2 adult tickets. Okay? So for that A, I'm going to put in the number 2, and those are still $8.75. Okay? They bought 3 children's tickets, and those children's tickets still cost $6.50 a ticket. And then they bought 1 senior ticket. Okay? And that senior ticket, oops, I want it in black, sorry, cost $6.50. So I want you to see what we mean by substitution is we're literally taking out the letter and putting in a number value. Okay? Now this is like a giant order of operations problem. 875 times 2 is $17, and I'm going to add a 0.50 cents. Next multiplication, 650 times 3. Remember, I do all my multiplication from left to right before I do any addition or subtraction. 650 times 1 is just $650. I'm going to add all those together. $1,750 plus $1,950 plus $650 is $43.50. That is the answer. So again, we have to be able to write the expression. We have to be able to substitute in values. We need to be able to do order of operations to solve. Okay? Moving on. The Spencer family bought 4 adult tickets and 2 children's tickets. Did they spend the same amount? So let's look at this. So the adult tickets we said are $875. But in this case, for our A, we're substituting in 4. For children, tickets are $650. And for this, we're substituting in 2. Okay? Back to our order of operations. 8.75 times 4 is $35. I should have done that in black. Actually, let's do it in red so you can really see it. And then order of operations says I have to continue my multiplication. 13. 35 plus 13 is 48. Did they spend the same amount of money? No. So you write something like, I'm going to erase this. No, this would actually go up here. No, they did not. Spencer family spent more. Oops, color changed on me. Okay, I'm now going to erase all of this. Okay, and I'm going to go on to the next question. Whoa, look at that flip around. Okay, so now we have some formulas. They're going to give us the formula and we're going to substitute in numbers. The area of a triangular sail is given by the expression 1/2 base times height. You might recognize this from 5th grade. That is the formula for area of a triangle. So that thing all filled in. Does this look familiar? This is the base, and this is the height. What is the area of a triangular sail? 1/2 base times height. I know they don't have the parentheses in the problem, but I'm doing this because I'm literally now going to erase the B, erase the H, and I'm going to put in for base. They said 12. Oops. No. And for height, they said 7. So order of operations. 1/2 of 12 is the same as 12 divided by 2 is 6 times 7 is 42. Okay, so the answer is 42 inches. Next problem. Raymond wants to balance his checking account. He starts with $2,340. He writes a check for $140. If he writes a check, that means money came out of his account. And he deposited a check for $268. That means money went in. So order of operations, we do addition or subtraction, left to right, whichever comes first, because there's nothing else. There's no multiplication, there's no division list. So minus 140 gets me to that amount. Then I add 268, gets me to that amount. So the answer here is 2,468. Clear my annotations. Woo! Okay. I'm going to come back to 13 because I want to get through the word problems. That one's a little bit easier. I want to get through the formula problems with you. 14 or 15? 14, what? Whoa, no! How do I undo? Oh, let's see, there we go. Okay. The kinetic energy in joules of a moving object can be calculated from the expression. So this, hold on, sorry about this. No, I want this. There. 1/2 mv squared. So you need to understand as you read this problem that m is the mass, that's like the weight of the product of the thing, and v is speed. It's because v stands for velocity, and velocity is a fancy word for how fast something is going. So I'm going to erase the letter m. This is what I mean by substitution. And I'm going to put in the weight they gave me of 0.145. Okay? And then I'm going to erase the letter v. And for the letter v, I am going to put in 40. And that 40, it's kind of hard to see, I have kind of a mess here, is to the second power. Let me actually erase this and rewrite the whole thing. That is not what I wanted. Let's go back here. Where's my active inspire? There we go. Never know what's going to happen. I'm having so many problems. I'm still having problems. 1/2. My weight, my mass, 0.145. My velocity, or my speed, is 40. It is only the speed, it is only the velocity that is to the second power. So now I'm going to do my order of operations. The first thing in order of operations is grouping symbols, but there's nothing inside my grouping symbols. My grouping symbols just contain numbers. So the next thing is 40 squared, which is 1600. So if I rewrite this, okay. Now, because I'm actually multiplying everything, even multiplying by half, I can multiply in any order, but let's follow what we learned about order of operations, which means first take 1/2 of 0.145. So 0.145 divided by 2, that's a half of that. And then, so that becomes 0.0725. And we're going to multiply that. Whoops, I just said I don't use multiplication symbols here because I don't want you to confuse it with x's. Multiply that by 1600, and I get 116. That is the answer. So you are actually taking a science formula. This is actually a physics formula. But at this point in your math career, you are just putting numbers in. Okay, let's look at the next one. I think the next one's like, oh, what if? The area of a square is given by x squared, where x is the length of one side. Because in a square, right, all of these would be the same length. But area is base times height. And in this case, that's x times x, which is x squared. That's how we get that. Okay? But they told you with this. Mary's original garden was in the shape of a square. She's decided to double the area of her garden. Write an expression that represents the area of Mary's new garden. Evaluate this expression if the side length of Mary's original garden was 8 feet. So this is a little weird. Okay? So 8 feet. That means her original garden is 64. Okay? But now she wants to double. So if her original expression was x squared, if she wants to double it, that's 2 times x squared. Okay? And what they're saying is if you solve that, so if you take 2 and you take out the x, and you put in 8. 8 to the second power is 64, and then 64 times 2 is 128. So they wanted you to be able to write this expression, which is 2x squared. Okay? Now I'm going to go back and do this one. Okay, so we started this one in class. We're just going to substitute. So for the first one, 6, instead of x, I'm going to put in a 0 minus 0 to the second power. So order of operations, 0 to the second power is 0, but I need to leave space here. 6 times 0 is 0. 0 minus 0 is 0. Okay? I'm going to alternate colors so you can keep track here. The next one, 6 times 1, because that's x, minus 1 to the second power. Order of operations tells me I do 1 to the second power first, which is 1. Then I do multiplication. 6 times 1 is 6. Now the only thing I have left to do is subtraction. Okay. Let's pick another number, another color. Let's do orange. Next one, 6. I'm going to plug 2 in for x. Oh, I did that wrong. It's not 6. Oh, I completely did that wrong. What am I doing here? See, even I make mistakes sometimes. So, 2 squared is 4. 6 times 2 is 12. 12 minus 4 is 8. Okay. Next one, let's pick another color. Let's do brown. 6 times x, and in this case, x is going to be 3, minus x squared. And in this case, we're substituting in 3. So 3 squared is 9. 6 times 3 is 18. 18 minus 9 is 9. Okay, keep going here. Let's do black for this one. 6 times 4. 4 squared is 16, because we're doing order of operations. Do our exponents first, then go back. 6 to the 4th is 24. 24 minus 16 is 8. Okay. Maybe I wanted that one to be pink. I don't know. I don't know which one is which. 6, substituting in 5 now for x. Order of operations tells me that the first thing I have to do here is exponents. 5 to the second power is 25. Go back and do my multiplication after my exponent. 6 times 5 is 30. 30 minus 25 is 5. And my last one, 6 times 6 minus 6 squared. 6 squared is 36. 6 times 6. Okay. If you were to actually graph these, it's going to make a curve. It's going to be upside down. Hold on a second. I think there's one more problem that I do not have here. Looking for my book so I can do the back with you. Because I don't think I took a picture of the last one. The last one. Let's do it. Okay, so last one, let me move this out of the way. Come on, go, go, go. Oh. The last one, and you flip the page, involves a pyramid. That's your pyramid. Yeah, they have a better picture. The volume of a pyramid with a square base is given by the expression 1, 3, s to second power h, where s is the length of a side, and it's a square, so all four sides of the bottom have the same length, and the height, let's do this, that's the height, okay? Find the volume of a pyramid with a square base side length of 24. So a square base side length is 24. That's still going to be the second power. And the height they're telling me is 30. Okay, so order of operations tells me I first have to do grouping symbols, but there's nothing actually inside my grouping symbols. Next thing is exponents. 24 times 24 is 576. I'm going to keep that in parentheses. Order of operations tells me I do multiplication left to right, 1/3 of 576. Well, some people say, well, Mrs. Falk, let's like doing 576 divided by 3. Yes, that is why you do multiplication or division, whichever comes first, from left to right. Now we do 192 times 30. And the answer is 5,760. So when you flip the paper over, there is the answer. So hopefully this has helped you with how to do all of these problems. Oh my God, now I got to move this out of the way. It's not moving. Where's my camera thing? Oh, it stopped responding. Oh, that is so annoying.